Hey, so for today, I'm going to provision a simple AWS infrastructure using Terraform. The benefits of using Terraform is that you can version control, review, and collaborate on infrastructure changes just like application code. Key pairs are cryptographic SSH keys used to securely authenticate and access EC2 instances without passwords. Key pairs are like the master keys and ID badges that let you securely access your employees or EC2 instances in your office building. Even if someone breaks into your building, they can't access your employees' workstations without your specific private badge reader. It's important to note that if you lose the private key file, you lose SSH access to your instance permanently, or you can set up alternative access methods. Resource. Tell us private key. Give it a name. Private. Algorithm is RSA. RSA bits 4096. Another resource again. AWS underscore key pair. We give it a name of generated key. Key name Terraform dash key pair. Public key TLS private key that private that public key OpenSSH. Then another resource again. Local file where you will save the temp file. Local file, we give it a name. Private key. Content is TLS private key private that private key pair. File name that slash Terraform dash key pair that pen. And then we're going to output some variables that we can use on the other modules. Output, give it a name of key pair, name, value is AWS underscore key pair that generated key that key name. Another output, TLS private key fem. Value is TLS private key that private key fem. And we're going to create a module for this. Module key pair. Let's give it a source. Key pair. Terraform init. Terraform plan dash out aws.tf plan. Okay, and it will create this. And then let's apply. A VPC is a logically isolated section of a cloud provider's network where you can launch and manage your cloud resources in a virtual network that you define and control. They are fundamental to cloud architecture because they can give you the network foundation needed to build a secure, scalable applications while maintaining control over your network environment. Like an office building floor, you can rent an entire floor of a skyscraper. You can decide how to divide it into rooms or subnets, who can access which rooms, security groups, and whether some rooms have windows to the outside world or internet access, while others are interior offices or private subnets. It's essentially cloud providers saying, here's your own private piece of the internet where you can build whatever you need. Going now to create the VPC. We're going to expose. public subnet has a route to an internet gateway. Think of it as the building's main entrance that connects your floor directly to the street. Any server you put in the public subnet can receive traffic directly from the internet, just like how people on the street can see and access those street-facing conference rooms. You have to note that just because a room has windows doesn't mean anyone can just walk in. You still have security or security groups, firewalls, controlling exactly who can enter and what they can do. We're now going to create the public subnet. Let's create the variable first. Public subnet. Let's create the resource. AWS subnet. Public subnets. Count var that public subnet siders. PCID. Cider block. Element var dot count delete isang element var dot accs public subnet count that index plus 1 output public subnets value then here module networking source Terraform init okay, here are the resources that will be created. Terraform apply. A private subnet is like the interior offices and back rooms. They have no windows to the street and can't be accessed directly from the outside world. It has no direct route to an internet gateway. There's no street entrance to these rooms. These servers can't receive traffic directly from the internet, just like how people on the street can't walk directly into your back offices. To be able for private subnet to access the outside world, it must go through NAT gateway, which we will not cover. Even if someone breaks through your perimeter security, your most critical systems, databases, internal applications are in these windowless back rooms where they are much harder to reach and attack directly. We are now going to create the private subnet. We are going to expose the private subnet so we can use it on the other modules. Okay, so then that's zero. This is what the Terraform will create, and then let's apply. An internet gateway is like the main building entrance and lobby. It's the single point where your office floors connects to the outside world or the internet. Simply put, it is an AWS managed component that connects your VPC to the internet. Without internet gateway, your VPC has no internet connectivity at all. Completely isolated network. We are now going to create the internet gateway. AWS internet gateway. Let's run Terraform apply. Route tables are network routing rules that determine where to send traffic based on destination IP addresses. When your web server wants to download updates from the internet, it checks its route table. To reach 0.0.0.0/0, go to the internet gateway and sends that traffic there. So we are going to create a public route table container. Name it public. And then we will create a route to the public route table that directs all traffic to the internet gateway. And then we will link the first public subnet to the public route table so it can access the internet. And then we will create a private route table container for private subnets that can't directly access the internet. The private route table usually doesn't have an internet route but still needs to exist to handle local VPC traffic routing. Okay. Terraform will create this, then apply. Security groups are virtual firewalls that control inbound and outbound traffic at the instance level like EC2 and RDS. Unlike the building's main security that controls who can enter each room or area, security groups are like individual bodyguards that stick with specific employees wherever they go. For example, if someone approaches your employee to start a conversation, which is called the inbound request, and your bodyguard approves it, they automatically allow that person to respond back, which is called the outbound response. If you're going to pass return values from other modules, you need to set it as variable first and then you add a type. We're now going to create a security group container for public subnet instances. And now we're going to create a security group container for private subnet instances. And now we're going to allow public security group instances to SSH out to private security group instances. And now we're going to allow private security group instances to receive SSH connections from public security group instances. And now we're going to allow public security group instances to receive SSH connections from anywhere on the internet. And then we're going to output some returned values. Okay, I forgot. We will need to create a module. Security groups. Security groups. VPC depends on VPC IDs. Module. We will reference the VPC ID from the networking. Module.networking.pcid and the CIDR block. Module.networking.vpc CIDR block. Terraform init. Okay, these are the changes. Just like you hire different types of employees with different skills and assign them to different rooms in your office, EC2 instances are virtual computers that you hire from AWS to perform specific tasks. EC2 instances are your actual workforce, the virtual computers doing the real work in your cloud infrastructure, just like employees doing real work in your office building. So we're going to create the variables first. And these variables are from the other module, so we need to put them here so we can use them inside this new module. We are now going to create the public instance, AWS instance for the public subnet. We are now going to create an elastic IP and associate the elastic IP to the public instance. And now we're going to create the private instances for the private subnets. And now we're going to create the custom module compute for this. We put the depends on first. No, we need to issue Terraform init first. Form init. No, because it's okay. I issued a Terraform init before this. So resources that we created in AWS. So here we have the VPC, okay, and the subnets, public and private, route tables, public and private route table, okay, here, and then internet gateway, and then the elastic IP, so this one. Then we're going to see the instances. So we have a public and two private instances, and then the key pairs. So we have the Terraform key pair. Let's now see if we can SSH into our public instance. So this is the IP, the elastic IP that we created earlier. So now we got inside the public subnet, and then we're going to private instance, and now we're going to connect to the private instances. Okay, we're now connected, as you can see here, and then we're going to connect to the other private instance. Okay, so we got in here. And now we are going to destroy everything that we created. So Terraform Destroy dash dash auto approve. Okay, so don't do this on production, the auto approve. It's now destroying the resources that we created earlier. Okay, finally it's now destroyed. So let's see if the resources are really deleted inside the AWS console. So here, if we refresh this, okay, we have 0 running instance, and then on VPC we only have 1, which is the default. Subnets also destroyed, route tables, internet gateway, and let's see security groups. So we don't have any security groups. So that's it. So thank you for watching.